Hey everyone, so this is a quick intro into quantitative analysis. We're going to be using Qualtrics for this, and since this is an MBA class, um, I'm hoping this is most of this is a review for everyone. I'm anticipating it's been a while for everyone, and so we're going to run through some quick basic things, and then get into more rigorous analyses. But again, so I'm going to try to move quickly since at least the basic stuff you should be pretty familiar with so far. Okay. Okay. Before we get to analyzing these, the first thing that you're going to do is load the data and the survey. Okay. So I'll have a link here for the to import the survey, and then a link to import the data. And we've done both of those before. So you'll want to, let me just duplicate this really quick. You won't want to open either of those files because it'll create some problems. But what we'll first want to do is load the survey into Qualtrics. So you'll go to uvu.qualtrics.com. Then you'll go to create a project like I just did. You'll click survey, get started, name it whatever you want, and then we're going to import a QSF and choose file. That's where you're going to import the survey file. Okay, and then once we have that, and it's up and loaded, it'll look like this, exactly like this. Then you go to data and analysis. Your data page will be blank, and you'll go here to import, and you'll choose a file, and that's where you'll input the macaroni data. All right. So a couple of things before, just to get things rolling. Let me show you this the survey really quick. So this is a survey for a macaroni restaurant called the Mac Shack. So their customers took this survey, which measures their satisfaction. They indicated their satisfaction with music, their satisfaction with the service, food, their overall satisfaction, whether or not they plan to visit again, and the likelihood that they'd that they'd recommend Mac Shack to a friend or colleague. So this is the classic NPS. Also, in the survey flow, as they took the survey input which location they were at, and there's 3 different locations: location A, B, or C. Okay, so that's the survey. Now, when we get into quantitative statistics, one basic thing that we want to keep in mind is the type of variables that we're dealing with. And there's all sorts of categories we can give variables. I'm just going to simplify it for the sake of what we're going to be doing in class and what you will pretty much you would do throughout your career. We're going to simplify this into 2 different types of variables here that we'll be dealing with. One is going to be they're going to be continuous variables, and the others are going to be categorical variables. The difference is that categorical variables, you're just organizing. The variable serves as a purpose to organize a group of things or people into categories. Okay, so for instance, here we have. Location is a really good example. So if we go here, since location we can't really see that on the survey, but if I pull location up here, you see there's location C, A, and B. Okay, a lot of times in surveys, there might be a number associated with this. So say location A is 1 and location B is 2. And location C is 3. Those numbers don't really have a meaning. They're just like a placeholder. Okay, they're just telling us which category each, in this case, respondent belongs to. You could move those numbers around. It's not going to make sense to calculate like the average location, right? Because if the locations were 1, 2, and 3, that doesn't make sense. An average location of 1.45, what does that tell you? It doesn't tell you anything, okay? And so again, categorical variables, the number, if there's a number associated with them, is just to serve as a placeholder, okay? One example of this is, another example is plan to visit. Do you plan to visit again? Yes or no? This particular one, you could look at how it's coded, and we have a 1 and a 2, a 1 for yes and a 2 for no. Calculating an average for this isn't going to make any sense at all, right? It's a categorical variable. But it's good to know, what numbers are associated with each group. It's less important with as we go into analyses through Qualtrics, other analytical softwares. The number can become pretty important. Okay, so the other is continuous variables. Now, continuous variables, those are the number has meaning. It has a purpose. So take like miles per hour. Doing 30 miles per hour versus 70 miles per hour. You can calculate the difference between those two. You can calculate over a year's time span the average miles per hour that you've driven. Those numbers have an order. They have a value. And there's meaning behind that. Okay, you can't just arbitrarily swap those numbers around without getting things mixed up. You can calculate. You can add. You can subtract them, and that all like makes sense. Okay, you can add them to an equation pretty easily. Okay. Some other examples of continuous variables could be age, right? That one can actually be dependent on how you ask it. If I just asked, hey, enter your age, and they're putting in numbers, that would definitely be like a continuous variable. But if I'm putting it into groups, if I'm grouping it like 30 to 40, 50 to 60, or like however I'm grouping the age. If I was to do that here in the survey, like say this was ages 18 to 35, and this was 36 to 42, or whatever those groups were, the numbers then would end up being 1, 2, 3, 4, and 5, and that's where it becomes a little more tricky because it's like an average. You calculate the average age and it'd be like 3.5, and it's like that's not their average age. That's the average of the grouping, right? And so that one's can be somewhat in between, but I would treat that more as like a grouping variable than like a categorical variable than anything else. But for the most part, you have like age, typically, unless you're grouping it in a survey, that's going to be continuous. You have your weight, it's going to be continuous. The number of clicks that an ad got, that's going to be continuous. Okay. Whether or not they clicked, though, that's going to be categorical, right? A group for those that clicked and the group for those that didn't. So the one little bit more controversial one are going to be just normal scales like this. So how satisfied they were. You have like the likelihood that they recommend. Statisticians tend to sometimes say this is a little bit more groupy than continuous and things, but in marketing in general, we just kind of ignore what they say there. We tend to, and say, no, this is continuous, okay? Satisfaction goes up. We can calculate the average satisfaction. A satisfaction of 3.5 makes sense, right? We can do all kinds of calculations with this. And we do, okay, and that's marketing just in the business world, and it's also marketing in the academic world. So if I'm if I publish an academic paper with scales. Most of the time, I'm treating them just as continuous variables, like vast majority of the time in my field here, even in academia. So in this class, we're going to treat these as continuous variables, okay? Okay, so now that we've gone through that, I'm going to click Data and Analysis, and I'm going to go to Stats IQ. And this may take a little bit for yours to load. Mine was already prepped, so it's good to go. And here are the variables that we talked about. They're all here, okay? So the first thing we'll want to do is get a good sense with our data. So let's take this first of all. And as you go here, you'll see that there's these lines, and they're small, I know, but if there's numbers like 1, 2, and 3 with this, then that's telling you that this is a continuous variable, being treated as a continuous variable. So we'll want to make sure that all of our scales are continuous. This one has dots instead of numbers. That's because it's categorical. Okay, and you can see like here we have recodes. That's typically meaning that it's going to be continuous. For plan to visit again, it says categories there on the gray box. You get the same thing here for location. You get categories. Okay, so these are going to be our categorical variables, and these are our continuous. Make sure that that's the case. If for whatever reason our scales aren't coming in as continuous, but they're more categorical, then what we'll do is go to settings here, go to variable settings, and we'll change them here. You just go to edit, and you'll recode this way. Okay, you put in 1, 2, 3, 4, 5, next, and then it'll usually ask you, hey, do you want to do this to the other scales? And you say yes. Okay, but this one I should load in correctly. Okay, so let's say we want to get a sense for what was the average satisfaction with service. All right, so if all I have to do is select this and then go up here and click describe, and it'll pop up and tell me, okay, the average was 2.3, here's the median, here's the number of people that answered. It also give me nice percentages. You know, this is pretty low. We're extremely satisfied. You know, 0.7% of them were. And so this is kind of basic descriptive statistics for a continuous variable. So what we'll want to do for question 1 is input satisfaction with music and NPS. You can do those at the same time, and if you describe it, it'll run and give you both of those. So that's really easy. Everybody should know kind of what is going on with averages and median. Okay, you just probably haven't run it in Qualtrics before, but as you can see, it's super easy. So for question 2, we're now doing descriptive statistics, kind of, but with categorical variables. Okay. Again, I've mentioned this before, but take like location, the difference between them being in location A, B, or C. It's not going to make any sense to calculate the average for that, right? An average of 2.76 for location. What does that even mean? You don't even know. And so for categorical variables, though, if we do descriptive statistics for this, if we describe them, it's going to show us the frequencies for those categorical variables. So the frequency, the number of people that were in location A, and the percentage that were in location A, and then it'll do the same for location B and C. For plan to visit again, it'll show us the percentage of people that do plan to visit again and the percentage that don't plan to visit again. So I'm going to show you this one really quick. I'm going to do location. That one's will be the most helpful to show you to help with this. Okay, so here we have location. There's 42% that were in location A, 30 that were in location B, and 26.7 that were in location C. Okay, so that'll be helpful for you there. Now, there's one other concept that we need to. This is a good place to put this in. So I see these percentages, but what we want to know is we want to know a little bit more than this. I want to know is this reliable, right? 42, that seems pretty high compared to these others, but 30 and 26, can we say that statistically those in location there were fewer people in location C than B that took this survey? I'm not sure. Like in this case, let's say that this was a little bit different of a variable that'll help illustrate this a little bit more. Let's say that we had a categorical variable, and what it was just measuring, you were just doing coin flips, and it was measuring whether it was a head or a tail. Okay, and you ended up with 42.7% heads, and the rest were tails. Does that mean that if you ran that test again, there would be more tails than heads again? No, and of course not, right? Because there was a whole lot of chance involved in that, and so we want to know, when we're looking at the frequencies of categorical variables like this, we want to know, okay, is this distribution, is that like due to chance, or is this something reliable? Is it going to be like a coin flip? If I ran this again, are we going to get like the same proportions? Are we confident that we're going to get the same proportions, or was this just kind of randomness? So luckily we have a value that we can go to that shows us that the likelihood that this is random or due to chance, and that value is the p-value. And so again, that definition for p-value is the likelihood that what you're seeing is random or due to chance. I want you to remember that, because chances are you probably haven't had p-value explained that way, and it's a really good way to think about it and apply it. Okay, so this will give us our p-values here. So if I click here to compare the group, I have here the p-values that are in comparing each group to each other. So this so right here, this is comparing the proportion of people in location A to B. Down here it's location A to C, B to A, B to C. So it's comparing all possible combinations. Okay. To see a p-value, you just have to hover the mouse right here. So this one here, the p-value is 0.0862. Again, I know that's small, but if you're following along, you should be able to pull that up for yours. Now, the magic number with p-value. So first of all, if we're going to interpret this, a p-value of 0.0862 means that if we put it in percentage form, there's a 8.62% likelihood that the difference here between A and B is random or due to chance. Okay, is that low? Is that high? So that the magic value that is most commonly used is, we say if it's below a 5% likelihood, which means a p-value below 0.05. If it's below that, then it's statistically significant. Okay, and so in that case, we'd say, hey, this if it was below 0.05, we'd say, hey, this is something that seems reliable. It seems like if this, for instance, was below 0.05, then we'd say okay, it looks like there is a higher proportion of people that from location A that took the survey than location B. All right, so we're looking at the percentage and the p-value here. And so but in this case, the p-value is greater than 0.05. It's 0.0862, and so In this case, it's at least below 10%. So we'd say like, okay, it's marginally significant, but it's not below the 0.05. It's not below 5%, and so it's not statistically significant. So even though there's a 42% in location A and 30% in location B, which seems high, it's not statistically significant. Okay, and especially if it's like greater p-values, like a 0.6, 60% likelihood it's due to chance. In those cases, you treat it like a tie. We weren't able to see any statistical difference between these groups, and so you treat it like a tie. Even though you can see a difference in the percentage, you can't rely on that percentage difference. And so it's, who knows what it's going to be like the next time you run this test. And so you treat it like a tie. Okay, so in this case, we would treat it like a tie, even though there's like a marginally significant, because it's a 0.08%. That's not quite significant, but it's below 0.1. So typically we'd say it's marginally significant. Okay, so this is a better example of a non-significant is B and C. That one, it's not significant. Okay, there's no significant difference between the number of people in these two groups. So that one I would treat like a tie. In the real world, it's just a matter about the amount of risk that you're willing to take. If you have a p-value of 0.08, okay, that's marginally significant. Maybe we go with, blank versus blank, whatever it is that we're dealing with. So let's say in this case, you wanted to make some type of decision from this, all right? Maybe it's, do we add, let's put big money on this. Do we add, $500,000 in advertising to, do we add more, like $500,000 more in location C to increase the number of people taking the survey or something like that, compared to location B, because we have fewer people that took the survey. So let's add a bunch of funding here to increase the number of people from C taking the survey compared to B. I don't know that I would make that decision. I wouldn't, because in this case, location B and C, there's a 51.8% likelihood that difference is due to chance. So we're going to dump hundreds of thousands of more dollars into this to make these more equal? No, because that difference could be due to chance. Now, if I'm looking at A and C, and this is a p-value of 0.0186, so the difference between A and C, that is significant. There's a 1.86% chance that it's 1.86 likelihood that it's due to chance. That is significant. So if it was something that really mattered to us and we wanted to get these equal, and the question is, okay, are we going to dump this money or not? I would be more inclined to do it for location C compared to A, because that is significant. But if we wanted to get it to as close to B, there's so much chance involved with that. The next time we run it, there might be more in C, or less. Like who knows? Okay, and so we just that's how we interpret p-value, and we'll be using that a lot more coming up. Okay, so then the other thing that we need to take into account, what we're going to do is we're going to move on to relationships. We want to look at relationships between variables. We want to see, are two variables related? Does one variable predict another variable? Oftentimes, the variable that we're seeing, if it predicts the other, that variable we're calling our independent variable. Qualtrics uses it as our input variable, okay? And we're seeing if that input can predict an output. That's going to be our dependent variable. So is there a relationship? And whenever we're testing a relationship, we just by default have to select one as our predictor or input, and the other one as our outcome or dependent variable, or our output. Okay, so you can tell by the way the questions are phrased. So while testing the relationship between plan to visit and satisfaction with music, you find that those that plan to visit again compared to those that don't. So your input here is, okay, visit again compared to those that don't. What's the output? What's the thing that we're really like interested in looking at? So if we put input visit again compared to those that don't, what's our output for satisfaction with music? What's that outcome going to be like? This one, so location, you're looking at, you're inputting, okay, whether they're location C or A, so location is going to be your input. Same thing here. Same thing there. And then here, this one's saying while testing whether SAP music, server, food, or NPS predict. So those are going to be our inputs. We want to see if they can predict our output of overall satisfaction. So that's kind of how we go about it in this assignment. And usually in real life, it makes sense. Now, just because we've talked about that, just because there's a relationship here, and it seems one predicts the other, that does not mean that this causes the other, right? We need to run an experiment to test if it causes the other. But we can see that we can still test if there is a relationship and what that relationship consists of. So let's look at this one, okay? Now, when we're looking at relationships, they're all going to be dependent on whether it's we're dealing with categorical variables or continuous variables, whether our input is categorical or continuous, or our output is categorical or continuous. And typically there's like a stream of, I showed different analyses that we do at different times depending on whether our predictor or our outcome are going to be continuous or categorical. Okay, with all those combinations, there's different things to do. The nice thing with Qualtrics is it'll automatically run the analysis that we need. And so all we have to do is select the two variables. So if we're looking at plan to visit again, okay, here's plan to visit again. I'm going to deselect this, and satisfaction with music. I'm going to do satisfaction with service, just so I'll show you that, and then you can do satisfaction with music on your own. So I'm going to click not describe, but relate. We're going to see if these two variables relate. But quickly before I do, let's talk about this key here. The key, Qualtrics by default will have the key be your output. Okay, so whatever your output is, you want the key to be there. So in this case, my output should be satisfaction with music. I'm going to do satisfaction for service for this example. So I'm going to click the key there. There's a couple of things that we can do with this. If for whatever reason, like say here we have a bunch of predictors that we're doing at one time that we want to see if it does that one outcome. So we may want to select all those predictors in the outcome and run that, and that'll be great because our outcome would be there. But you may be in a situation where it's the other way around. You have a bunch of outcomes and one predictor. You want to see if it predicts all these different outcomes. In that case, you could click this and it changes it so the key becomes your input or your predictor. So that can be nice in some situations. In this case, we're set here. So I'm going to click relate. So here in this case, we have a categorical predictor and a continuous outcome. It's gonna run a t-test here. It might run ANOVAs if we have like a bunch more categories or more than two categories. Okay, so here we have this. It's nice. It gives us a nice sentence. It's saying yes, it tends to have higher values. A yes, that they will visit again. They seem to have higher values for sat with service, so they had a higher satisfaction with service. But the right here is it's going to give us our p-values. This sentence, if it's not significant, it'll say no, there's no relationship here, right? But if it is, it's usually because there's a significant p-value. This p-value is super, super low. Okay, so it's telling us, man, there is a definitely. I mean, this is like a 0.0001% chance that the relationship between plan to visit again and service satisfaction is due to chance. Okay, that's super low. This seems like something that we can really rely on. All right, so there's a p-value, and when you're dealing with this type of instance where you have a categorical predictor and a continuous outcome, the averages are going to be shown here. Okay, for every analysis, there's going to be a p-value and then a way to look at what that relationship is like. And here you see the yeses had a higher average than the nos. All right, so that is whether they that's here, plan to visit. Let's do the same. I'm going to do satisfaction with service again as my outcome. But for question 4, I'm going to have location be my predictor. So this one's going to be a little different, okay? Now that we have more than 2 categories, we're still going to get a p-value here. All right, okay, is something going on? Is there a relationship? Yes, there seems to be a relationship. Here's the averages. But the trick here, this is running an ANOVA, and you can see that here, ANOVA and t-test. The trick here with ANOVA is that just because there's a relationship doesn't mean that all these categories differ from one another. For instance, I'm guessing based on this p-value, there is going to be a difference in satisfaction with service between location B and C. But I don't know, like, if that goes to, does location A significantly differ from location B? There's a difference, it seems like, in the averages, but is that something I can rely on, or is that due to chance? I don't know. This isn't going to tell me whether all of these differ. It just is telling me, hey, very high likelihood that at least one of these significantly differ from the others. So what I'm going to do here is go to show pairwise test, and this is going to compare all of the categories to each other. All right. So in this case, I look here between location A and B, and here's my p-value between location A and B. And what I'm seeing there is it's not significant. All right. So this difference here, I'm going to treat it like a tie, because that didn't meet that threshold that I'm looking for between 0.05, less than 0.05. This is 0.113. And so I'm going to say, yeah, there's an average. The averages seem to be different, but they're not significantly significant. They're not statistically significant. There's an 11% likelihood this is due to chance, so I'm going to say that those are similar. I'm going to treat it kind of like a tie. Location C, though, you can see the location C's here. It's marginally significant than A, 0.06, so that's below the 0.1, so I'd say that's marginally significant, but not quite significant yet, right? But definitely the difference between location B and C, that is significant. So location B outperformed satisfaction with service from location C, and it marginally, location A marginally outperformed the satisfaction with service for location C, right? But we didn't really capture a significant difference in satisfaction with service between locations A and B. Okay, so for this next question, we're dealing with plan to visit and location. So in this case, both are categorical. I'm going to make sure that plan to visit is my outcome. So I'm going to click this, click relate. Just like before, we're going to get a p-value. So this is a p-value here. Yes, that relationship seems to be significant, right? Something's going on there with that relationship. And here's the percentages. So I can see, okay, for location C, 47.5% said they would visit again. There's 78.3 and 51.6 here that said that they would visit again. So that seems cool. There's here we're getting some arrows. These are going to help us out in the future, but it's a quick pop out to see, hey, something significant is happening here. If there's an arrow or 2 or 3, you can tell something significant is happening with this group. But I can do the same as my ANOVA here and look at pairwise comparisons. And in this case, I see here this is significant. It doesn't give us the exact p-values here, but so there's between location A and B, this is significant. Okay, so if I'm looking here, oh, it looks like there's more people in location B that would visit again than location A. All right, so these ones are not going to be significant. These ones are, and these ones aren't. So look at the p-values here. Look at the percentages there. There may be some cases where we want to look at other categories. This one's pretty simple because our outcome only has 2 categories. But say like maybe this was swapped, and what it'll do is it'll just show one of the outcome categories at a time. So here, this is looking at whether there's a difference in no's and yeses for location A. I can go here to location B. Okay, there's a significance. And then location C, and see there's a significance, right? For this question, though, we won't be doing that. But that's just, if there's more than 2 categories for our outcome, we're going to want to look at these one category at a time. Now for this last question, these are all continuous, okay? Our predictors and our outcomes are all continuous. That's going to do a regression. So here I'm going to do, sat music and, well, let me do sat music and sat service. I'm going to run this to relate these. And what I'm going to get is, again, p-value, like always with all these. But because these are both continuous, we're going to deal with a beta, okay? The beta tells you whether or not this relationship is positive or negative. If it's positive, that means as your predictor or your input, as it goes higher, your output is also going to go higher. A negative relationship means as your input or predictor gets higher, your output will get lower, okay? So in this case, as sat service as our predictor, as it gets higher, satisfaction with music also gets higher. With a negative relationship, this would be going down, okay? And so this is our beta right here. This is in this little equation here. It's 0.631, which means as satisfaction with service, as it increases by like 1 point, we'd expect satisfaction with music to also increase, but we'd expect it to increase by 0.631. All right, so as our predictor goes up by 1, we'd expect this to go up by 0.631. If there's a negative relationship, this would be a negative 0.631. And so as our predictor goes up by 1, we'd expect our outcome to go down by 0.631. That's how we look at that. For this one, you're looking at multiple predictors. We want to know which one's most important. Since they're all scales, it makes it easy to know which one is the most important. We want to look at run them all, and you can, as I mentioned before, go like this, and then just have overall sat as our outcome, and run that, and it'll do it for all of them. So you want to know which ones are significant, and among those that are significant, which one has the highest beta, and that'll tell you which one is the most important. So that's what you'll want to look at there. So that's a quick run through of quantitative analysis for this class.